Today we are going to do differential equations. What is a differential equation? An equation in which the derivative itself acts as a variable is called a differential equation. For example, suppose you have an equation like this: dy by dx is equal to y divided by x log x. Suppose you have an equation like this. This is called a differential equation because apart from the usual variables x and y, dy by dx itself is a variable which is an unknown. Now, if you can establish a relation between x and y without involving the derivative, that is called the solution to the differential equation. So, we are essentially going to find the solution to the differential equation, and in type 2 of the sheet, we are going to discuss the first method, that is called separation of variables. And specifically we are going to begin with sum number 4 part 1. In sum number 4 part 1, you have dy by dx equal to y divided by x log x. So you can write this equation as dy is equal to dx by x log x. So this is integration dy by y is equal to dx by x log x. So integration dy by y is log y is equal to log x plus c. So we are getting log y is equal to log x plus log a. So y is equal to a log x. So you can see that we began with this differential equation and we managed to establish a relation between x and y which does not involve the derivative. So this is the solution of this differential equation, and this technique is called separation of variables because what we basically did is we separated the y and the x and then integrated both sides. Have a look at question number 8 part 1. It says dy by y is equal to 2x dx by x minus 1. So this is something which can be written as dy by y is 2 into x minus 1 plus 1 dx by x minus 1. So we are going to get dy by y is 2 plus 2 by x minus 1 dx. Now you integrate both sides. So you will get log y is equal to 2x plus 2 log x minus 1. It is given in the question that when x is equal to 2, y is equal to 1. So log y is 4 plus 2 log 1 plus c. So this gives us c is equal to minus 4. So log y is equal to 2x plus 2 log x minus 1 minus 4. So we can write log y is equal to log x minus 1 whole square plus log e to the power 2x minus 4. Now you can take log common, so the answer will come y is equal to x minus 1 whole square into e to the power 2 into x minus 2. So this is the way to do separation of variables, and we have seen 2 examples of that. Now we come to type 3. Type 3 talks about homogeneous equations. What is a homogeneous equation? First of all, what is a homogeneous function? A homogeneous function is a function which can be written in this form: function of x comma y is equal to x to the power n into function of y by x. Any function which can be written in this form is called a homogeneous function. So suppose you are doing question number 9 part 1. So dy by dx equal to y by x plus sine of y by x. Now you can clearly see that the entire left hand side is a function of y by x. In all the sums of type 3, the method will be, you will have to begin by saying let y equal to vx. So dy by dx is v plus x into dv by dx. So v plus x into dv by dx is equal to v plus sine v. So dv by sine v is equal to dx by x. Now you integrate both sides. Now integration of cosec is log tan half the variable, and this side it will be log cx. Now what you do is you remove v and put y by 2x. So this is the solution. So just remember one thing: in all the sums of type 3, you will first need to verify that yes, it is a homogeneous function. You will have to start by putting y equal to vx, and then you have to replace everywhere y by x with v, integrate both sides, and you will get the answer. Now we come to type 4. Type 4 talks about linear equations. What is a linear equation? A linear equation of first order. Suppose if you have an equation like this, let us say you have an equation like this, dny by dxn plus pn into dny by dxn plus pn minus 1 into dn minus 1y x n minus 1, and so on. And suppose this is one equation. In this equation, pn minus 1, p0 are all functions of x. You have n orders of derivative. This is the nth order, this is the n minus 1th order, and so on. You will notice that in this entire equation, the power of the derivative is always 1. Such an equation is called a linear equation. Now we are only talking about linear equation of first order. So if you have an equation like this, dy by dx plus py is equal to q, then this is called linear equation of first order. The method to solve such an equation is you will have to first find the integrating factor. Now, integrating factor is found by a formula. The formula is e to the power integral p dx. This is the method to find the integrating factor. Now, in any question of this variety, once you multiply both sides with the integrating factor, the left hand side will become a perfect differential. For example, suppose you are doing question number 16 part 1. So it says y dx plus x minus y square dy is equal to 0. So y dx by dy plus x minus y square equal to 0. So dx by dy plus x by y equal to y. So you can see that this is a linear differential equation. Now for this equation, the integrating factor is e to the power integral dy by y. So that is coming e to the power log y, that is equal to y. Now if that is the integrating factor, what you have to first do is multiply both sides with y. So y dx by dy plus x is equal to y square. Notice that the left hand side has now become a perfect differential. So you are getting d by dy of xy is equal to y square, and now if you integrate both sides, then you will get xy is equal to y cube by 3 plus c. So this is the way to solve the sums of type 4. Now we come to type 5. Now in type 5, you will be given sums with second order derivative which have to be integrated twice. Suppose you are doing the 22nd sum. So 22nd sum x into d2y by dx square is equal to 1. That means x into ddx of dy by dx is 1. So d of dy by dx equal to dx by x. Then you integrate both sides. So dy by dx is log x plus c. Now if you put x equal to 1 and dy by dx equal to 0, then you will get c is equal to 0. After that, you get dy by dx equal to log x. So dy is equal to log x dx. So dy is equal to x into log mod x minus x plus c. Now it's given that y is minus 1 when x is 1. So c is coming 0. So finally, this is the solution, y is equal to x log mod x minus x. So this is how we do the sums of type 5. Now we come to type 1. Whenever you have a differential equation, the order of that equation is the order of the highest order derivative in that equation. Like say for example, if you are doing sum number 1 part 4, then in this equation the order will be 2, because the highest order derivative is second order. Now the degree of any differential equation is the highest power of highest order. So in this equation, if you square both sides, you will see the highest power of d2y by dx2 is 2. So this equation will be of order 2 and degree 2. And apart from this, type 1 talks about linear equation. We have already seen what is a linear equation. So that completes type 1, and it also brings us to an end of this session of differential equations.